So today we're gonna start doing rational functions. Now rational functions are cool in the sense that the reason why they're named rational function is because you're creating a ratio between functions. And today we're gonna start by using x plus 3 over x squared minus 4x plus 3. Now this is a typical rational function. You have a polynomial on the top, x plus 3, and a polynomial in the denominator, x squared minus 4x plus 3. Now, in order to draw the rational functions, we're going to need a few things. Number one, horizontal asymptotes. Specifically, those are the asymptotes that go across the horizon from left to right. And it is the line that the curve approaches. So as the numbers get infinitely bigger, this curve will get closer and closer and closer to that specific line. Second thing that we're going to find is called the vertical asymptotes. There could be more than one. And usually they're the lines that will make this statement false. Specifically, you can make this statement false if you make the denominator equal to 0. Now we'll explain later on how we're going to find those lines specifically. And 3, and then right here in the corner, we need a table of values. Now this one's the easiest one of them all because we're going to pick values of x. And we're going to plug them in to get values of y. Now, first thing we're going to do, find the horizontal asymptotes. Now, in order to find the horizontal asymptotes, we need to compare the polynomial in the numerator, x plus 3, and the polynomial in the denominator, x squared minus 4x plus 3. What we're going to compare specifically are their biggest power, the numbers that are in the corner of the biggest term. Now in this case, the powers are, on the numerator, 1, and on the denominator, they're 2. Now, we have to decide which one greater, and of course, by just looking at it, we know that 1 is less than 2. Whenever we have the case that the power in the numerator is less than the power in the denominator, we have a horizontal asymptote that will always equal to y is equal to 0, which so happens to be the x-axis. So far, we've done the horizontal asymptote. Next, we need to do the vertical asymptotes. Now, vertical asymptotes are a little bit more complicated, insofar that we're looking for a false statement. Now, the only way that we can have a false statement in this case is when the denominator equals to 0. That's why usually, whenever we write a rational function, we always state that the polynomial in the denominator cannot be equal to 0. So, what we're going to do is factor out the denominator. And when we factor out, we get x minus 3 and x minus 1. And then set each factor equal to 0. Because it takes only a single factor to make the statement false. So we got to make sure that we avoid them overall. That's the reason why we make each factor equal to 0. Now, we get that x minus 3 is equal to 0, making x equal to 3, and x minus 1 is also equal to 0, and x is equal to 1. 3 and 1 are the numbers that we cannot have, but they're also important because they are, by definition, are vertical asymptotes. Okay. And in fact, vertical asymptotes are just numbers that we cannot have. They represent the numbers that cannot be. Our last step is going to be to find a table of values. Now, calculating a table of values is a little bit time consuming, so I'm going to pause for a second and I'm going to calculate the table of values. All I'm doing is plugging in numbers of x, and we're going to get the values of y. Now, the reason why we do that is because these are inherently curves, and in order to draw a curve, we need a couple of points to get an idea of how the curve is going to look like. And all we're really doing is connecting the dots. Now, I've already drawn the table of values, and I also drew a Cartesian plane so we can graph the rational function. Now, the first thing that I'm going to graph is the horizontal asymptote. And as I said before, the horizontal asymptote is the y-axis. Now, I still want to mark it somehow. And as you can notice, as I mark with my blue pen, it doesn't seem to show very well. So what I like to do is go and highlight the x-axis. That way I can show that is the horizontal asymptote. Once we're done with the horizontal asymptote, we continue on to the vertical asymptotes. We notice that we have two of them. X is equal to 1 and x is equal to 3. 1 is this line over here. And it crosses a bunch of numbers, but that's okay. And 3 is over here. Once we have the horizontal and vertical asymptotes, we're going to start drawing the points. Now, the points are just to get an idea of what the graph is going to look like. But since the points are so small, it's really hard to tell. One thing that you should notice now, however, is that at -3, y is equal to 0. So the horizontal asymptote is different from the vertical asymptote in so far that the curve itself can cross it, unlike the vertical asymptote, which can never be crossed by the curve. So the horizontal asymptote becomes more of a general direction that the graph has to go rather than what I would say would be a true asymptote. Now we continue on. And once we get to 0, we notice that we get 1. And then once we have a couple of points done, we need to draw the rest of the graph. Now, as a general rule, this curve has to always be approaching the asymptotes, one way or the other. But most of the time, especially dealing with vertical asymptotes, it never actually touches it. So we just draw a line getting ever so closer to the asymptote, and then we call it a day. Now, the rest of the stuff, we have 2 and -5. And this one's interesting because this one's going to make a U shape, like an inverted U. Once again, it's still approaching those vertical asymptotes, but it never actually touches them. And the last one, of course, is the same thing as the first one. It's going to get near the vertical and the horizontal asymptote, but it's never going to touch it. Now, we have that 4 is 233, which is somewhere in here. At 5 is 1, and at 6 is 0.6. And that, guys, is how you draw a rational function. Now, this is not the only type of rational function. And as a cautionary note, notice that we could also have, theoretically, more vertical asymptotes. But usually we only have one horizontal asymptote.